our holiday. We're here this morning to present to you all about human systems integration, and Gordon Boss is our speaker, lecturer this morning. And I'm doing some housekeeping things. He's going to self-introduce, but before we get started, I wanted everybody to know we're here in Building 2. In the event that there is an emergency, we proceed out this door right here and go out on the other side of the hedge. The restrooms, when you go out this door and turn to your left, there's a men and women's restroom right there. And my name is Janice Hall, and I am the manager of the Business and Institutional Management Office, under which the Human System Academy here in the Human Health and Performance Directorate falls. And so we're glad that you all are here. And I will just let you know before he gets started, because he's going to leave time at the end for question and answer, that our next Human System Academy activities that we have, today's introduction to human systems integration. We have human flight research integration. Suzanne McCullum will be the lecturer for that. And that's on the 27th. Exercise countermeasures, Linda Lurch, Laura Plout-Schneider, and Mark Gilliams. And that's on February 3rd. And exercise and countermeasures lab, after they've done the lecture, that is going to be on February 10th. So all of those are listed in Saturn right now if you are interested, and we encourage you to please sign up and engage with us. And without further ado, Gordon Boss.
Thank you very much. She said I would self-introduce. I'm not sure how much of a self-introduction is necessary. I'm a guy. I work here at NASA. I do HSI. I have been here for almost 8 years now. And as you can see from the slide, there are a lot of people who contributed to this. I just happened to get elected to be the mouthpiece. A lot of folks, in fact, one of whom is in the room, had a lot of good inputs to this. And I should be able to answer any questions you all have. I've been doing this for about 3 years now, this particular slide deck, with a couple of minor tweaks here and there. There are some recent developments in HSI, and if I get stumped on any questions, I might have a call out to the one person in the audience who could help with that. So without further ado, what we're going to talk about is just 3 basic ideas about HSI. You know, what is it? What does it mean? How do we define it? You know, what does it mean to you as a person who works here? How does it fit in Section 2 with the engineering and integration lifecycle? How do we make it work? And then finally, Section 3, how do we actually implement it here within our NASA environment, as opposed to other environments where it's been done? So, starting off, what is human systems integration? Well, the simplest way to explain it is just to say that it's a process, and it's a process that makes sure that we account for the capabilities of people, their limitations, their strengths, their weaknesses, and all of that into the design of a system or an object or a software, whatever it may be. It can be applied to something as small as a particular component or something as large as an overall program. The way we implement it as a process tends to take that larger view. A lot of the things we're going to talk about could be applied to a very large project. They could also be applied to an AES or smaller scale type of project, and the way that you apply it might be tailored a little bit based on its size. But the overall goal is to reduce the life cycle costs of that overall engineering development process. Preventing rework is probably one of the main focuses. Too often we'll design a system and we'll go ahead and implement it and then find out later on there's some sort of a problem. We've got to go back and change it. And that's much, much more expensive than taking into consideration all those human needs at the very beginning of the process. And the key takeaway from this slide is that it really puts humans on par with the other aspects of the system design. They're not just an afterthought, they're not something that you just have to work around, and no one would actually think that out loud, but sometimes it tends to happen when you're in your own microcosm, you know, you're engineering a particular tool or, you know, aspect of a system, to think about how it plays with the other ones. So the formal definition is that it's an interdisciplinary and comprehensive management and technical process, and it focuses on the integration of human considerations into the system acquisition and development process. This is a very dry definition, by the way, I apologize. To enhance human system design, reduce life cycle ownership cost, and optimize total system performance. What this means is tailored somewhat to the federal procurement process. It mentions here the acquisition of a system. This is key for working here at NASA or within the DoD or other agencies in the federal government, where we don't typically just design our own thing and then build it ourselves. We create requirements, we create documents that specify how we want something to work, we put it out for bid, and then we get proposals back from different vendors, then we pick a prime contractor or a collection of different contractors. This is a system, a process that ensures that what we get back is going to take into consideration all of these human aspects of the design. So one of the things that HSI tries to do is continually revalidate the original intent of the system. I'm not sure if it's on this slide or one of the other ones that comes later, but there's a concept of not only getting the design right, which is basically meeting your specifications, meeting your requirements that you've laid out, but also getting the right design. What is it that you originally set out to get as far as a solution is concerned? What is the mission of this thing? And looking at that and all the different things that the person might do with it, and by person, a human, we could be talking about flight crew, we could be talking about ground engineers, we could be talking about manufacturing, assembly, maintenance, turnaround, all sorts of different aspects of it. Anyone that might come in contact with that system. And even fully automated systems still have a human contact point. Robotic missions to the Mars surface, they have drivers that operate those rovers. They have science teams that download and interpret the telemetry. They had a ground operations group that helped package the assembly for that launch and all of that sort of thing. So all of those different aspects come into play. And the goal is to continually take lessons learned from past designs and feed those back into our new designs, iteratively, over and over and over again, and continuous improvement loop. And again, the overall goal, the way that we can try to sell HSI and make sure that it happens, is cost containment. Making sure that we don't have to rework things later on, a year down the road, 2 years down the road, or whatnot. And yeah, I think I've already talked about the bottom part there, so I'll go into the next one. What we're trying to prevent is the system where, and it's not just a NASA thing, I've seen this in the military as well, where we'll design a system and the people who have the responsibility and the authority for designing and managing the project costs for the design and development are a totally different group sometimes than the people who actually operate that system and have to train people to use that system and deploy it. And we call that throwing it over the wall, and we don't want to do that. We're trying to find a way to take into consideration the overall life cycle cost, not just development and not just operations. So looking at studies that have been done of different environments, the International Coalition of Systems Engineers has come up with this particular chart, and what it's showing is that as you go through the design life cycle, where on the far left-hand side of the chart you have the very ideation of the idea, the concept that you've come up with, and then you have the design, the development, the production and test, and then the final operations. The costs of making changes to fix a problem that you discover go up significantly as you go through time. And the ideal place to have that human systems integration engagement and start thinking about what are the real human needs of the system is at the very, very beginning. 80% of the costs are going to be operational costs when you look at the overall life cycle of a particular project or program. And once you get over here, the cost of making that change can be up to 1,000 times higher than it would be if you had made it back at the concept stage. So it's really key to try to get involved early and frequently. So the DoD has done decades of research on this. They have I don't know if I call it a benefit, but they have a fact of life where they have to deal with larger production numbers. We may build a certain number of shuttles or a certain number of capsules or something like that, but they'll have hundreds of thousands of units of a Humvee or something like that. Even their most expensive aircraft, they might have 50 to 100 in a production run. So they have that extra educational opportunity where they can make those changes on a more regular basis than we can. So we're trying to learn from what they've done. And one of their studies found out these different lessons learned, and we're trying to apply them here at NASA. The main thing was that operations information wasn't being incorporated into the design. And in particular, it wasn't the people who actually do operations. There may have been a manager involved or someone like that that had done operations 10 years before, but they were not really on the ground anymore. They didn't have that day-to-day experience anymore. So trying to get the operations phase personnel deeply involved with the design process itself and helping set up what are the goals, what type of maintainability requirements would you have, what type of turnaround requirements would you have, what are the things that would really make a difference. And going ahead and setting those up from the very beginning, and then as you go through and you have different design decision points, you know, KDPs, key decision points and things like that in the engineering life cycle, we'll talk about that a little later, making sure that the criteria for getting through those decision points look at that cost, look at those operations goals and make sure they're still valid, that the design still does what you wanted it to do. The other thing that they came across was that there were different cultures between operations and design and development. Different ways of doing business, different ways of thinking about things. And in particular, there was not a sharing of responsibility across that wall that we mentioned before. That the person who was in charge of doing the design, the program manager or whoever it may have been, they had no responsibility for the actual operational cost. And they had their budget and they just had to stick to that budget. And so if they had to shave, you know, benefits here and there to keep things under cost control, well, sometimes you have to do that, but trying not to do it to sacrifice the long-term goal. And having, you know, the default be, well, we can't do this with the design, so we'll just train around it. I mean, we never want to do that. That's kind of an obvious example, but the other thing is that there's a shortage of tools for how do you look at that cost? How do you quantify something 10 years ahead of time? What it's going to cost you to actually deploy something and operate it for another 20 years. And that's actually a struggle we still have today. We don't have a, you know, an ultimate answer for that here in this presentation, but it's something we're aware of and something we're working on. The other thing is that the HSI community was isolated. It was in a silo. They had great people doing HSI in the DoD for many, many years, but they weren't really connected well. And you know, the studies that have been done have helped them overcome that, and now they're spread across the agency in a much better way. So we're trying to do the same thing here. That's the reason we're having courses like this, is trying to get the word out. So one really good example from the DoD world is with the F-22 Raptor engine development. This was back in the early 80s, and the military in particular, all the different branches, had noticed significant costs associated with the logistics of maintaining things like jet engines and helicopters and all of that. And those logistical costs were huge. They were by far the majority of all of the operational costs they had. And so the Army, the Navy, and the Air Force got together and created this Joint Advanced Fighter Engine Program, JAFE. And what they wanted to do was make sure that the next strike fighter, so to speak, that they developed, the next fighter plane that they had, you know, really took into consideration that maintainability and serviceability aspect, had the human considerations taken into it. And so they outlined in their requirements and in their requests for proposals from vendors for developing this engine that they wanted to have an RMNS, a reliability, maintainability, and sustainability program. Wanted to reduce part counts, wanted to eliminate maintenance, nuisances, special use tools, wanted things like common fasteners, single line replaceable units, so that instead of disassembling all the little intricate details of part of an engine, maybe a part of it just comes out as a unit and you just replace it with another unit. And that's been very successful, by the way. They do that all across the military now. So in response, I should say also they put out two different contracts for development of a prototype to two different vendors. So in response, one of the vendors just did business as usual and turned in a prototype. It had a very high part count, it had a very high special tool use count and some other things. The other one, on the other hand, really went all the way with its RMNS capability. They went into the field, they went into these shops where they maintained current engines and things of that nature, asked them and interviewed the people, the frontline people. What would you do differently? What could you change? How would your job be made easier if we did this or that? And they did that for quite a while, and in the end they came up with several different prototypes. Some of those prototypes they actually had these engineers work on as kind of a test bed, you know, a pilot study if you want to call it that. And those mock-ups really helped development of this final engine. In the end, the final product they delivered was serviceable using only 6 hand tools instead of how many, I don't even know how many, it's probably in the hundreds. And they had this concept of a line replaceable unit, and that's very common across the board in the military now. This is one of the first cases we really saw it, where again, individual components can be removed instead of having to get in and individually tweak individual stators in the engine and things of that nature. Each one can be changed out in 20 minutes using only one tool. This right here, the hazmat gear and the percentiles that I have, the lower button bullets here in the middle, those are very important. That really gets to the human maintainability aspect that could easily be missed. So an engineer sitting down at his CAD workstation coming up with a design may have an elegant, beautiful design. But these particular engines might fly through a combat zone where a radiological device has gone off, a dirty bomb, or some sort of chemical weapon has been used or something like that. And so the crew that services that jet when it lands, they can't just get in there with their hands and their mechanic gloves. They've got to pull on a full personal protective suit to protect them against that chemical or radiation or biological hazard. All of a sudden their hands are 30% larger and have lost a lot of dexterity. That significantly impacts how you do this. And I've heard firsthand testimony from a small person who she was chosen for her job, particularly because she was so small. She was the only one who could climb inside the wing of a particular airplane to clean out the gas tank, basically, that was inside the wing. And she couldn't wear her personal protective equipment. She had to suck on a tube to get fresh air instead of breathing in all the fumes from the jet fuel and stuff. And the contact exposure of absorbing that fuel through her skin. So that's a real world example of where it hasn't been done well. This fixed a lot of problems. And this 5th to 95th percentile requirement, what that refers to is the size of a person. And it could be of any number of different dimensions. It could be your total height as a person. It could be your width, your girth, individual size of your hand joints or something like that. It's a very difficult concept to try to explain, other than it just relates to how large or how small you are in different aspects. So a 5th percentile person would mean that 95% of people are larger than that person in that dimension. If we're talking about stature, I'm 6'2", I'm a 95th percentile person, which means 95% of people are 6'2" or less, and only 5% of the population are taller than me. That's really important so you don't end up by assigning jobs like this poor girl had, where she just happened to be 5'1", she was the only one who could fit in the wing, and so she had to do it every single time. She had no opportunities to do other jobs, and she was held there longer than she should have been for that very reason. So it has far-reaching implications beyond just that serviceability aspect. And in the end, they reduced the number of ops level maintenance items by 75% and the tools by 60%. So the way this worked out and the way that they got what they wanted was, as an agency at the DoD, they came together and they had very firm requirements about this HSI concept, which wasn't really called that at the time. But these things, these aspects of reliability, maintainability, you really need to be sure to include these. These are very important to us. And they awarded the contract based on that, despite the fact that the other engine performed better, had higher horsepower output. It was a stronger engine, but this other one would significantly increase their costs, significantly reduce their costs to the point that it made up for that. They'd be able to have more of them produced. And that actually is a force multiplier for them, not just the power of the engine, but how many planes can they have. And there's more. You can actually research this in more detail if you want. I believe these slides can be put online and so that you can access them after the fact. Similar example, I won't spend a lot of time on this one. The T-53 series helicopter engine that was used back in the 50s and 60s had 134 different tools that was used to maintain the system. Manprint is the name of the Army's HSI group. And I forget what the acronym stands for per se, but they basically have been doing HSI for about 15 years or so at least. And as part of this Comanche T-800 process of design that they had, they were able to get it also down to 6 tools, just like the F-22 Raptor engine. And that's a lower burden on the supply system. They have to ship less tools to these different remote bases overseas and things like that, and make it much easier to service the helicopter. So the overall promise here, if you can do this, you can reduce the maintainability requirements, the serviceability requirements, the operational and training requirements. You can have fewer people that have to be burdened by that system, so you can save money there. You can have simplified requirements for personnel skills. Not everyone has to have a PhD in engineering to work on this engine. They could be, I don't know, but it would be something you could train them to do possibly, instead of having a pre-existing requirement. The training itself could be reduced significantly. Instead of having 134 tools, spending an hour on each tool teaching them how to use it, It's only 6 tools. I mean, that's 6 hours. That's a significant reduction. That's a very simplified example. Also avoiding mishaps and avoiding having to go back and re-engineer the system. So the design focuses, of course, on the needs of operators. We're going in with that, but also on the maintainers and other personnel. And one of the ways that we do this, again, get this return on investment, is making sure that all the stakeholders, including the operational stakeholders, are engaged early on. And the overall goal here, again, is more effectiveness and efficiency in the long run. Any questions so far? Just kind of up here rambling away. Okay. This is just another way to share the same kind of philosophy. You know, we have a way that we estimate costs in the systems engineering lifecycle. We have a concept of a pre-phase A, phase A, and a phase B. These are different stages where we define the different aspects of the project. Pre-phase A is kind of that concept stage where we're coming up with the idea and we're working up our design reference mission and things of that nature. Phase A, you start to do your initial design kickoff and start to get things going. Phase B, you know, goes right up to a PDR, a preliminary design review. And by then you've actually got, you know, schematics, you've got some things down, you've got a trace of requirements and things of that nature. It's very important to get involved very early on in that pre-phase A area. Because once you start to get out here again towards the design and the integration and the delivery, the costs ramp up significantly. An example here at NASA that we saw was with the space shuttle. Originally there was a goal of something on the order of 20 to 40 launches per year. The number changes based on who you talk to, but it's somewhere in that range. And the best we ever got, and only in one single year, was 9 launches. On average before, it was more like 5 to 7 or something like that. So some of the reasons for this were simply the time it took to turn them around was a lot longer than we thought earlier on. The heat tiles were one reason for this. There were many other reasons. It was a very complex system, one of the most complex systems ever designed. And the level of training required to not only work on the system, but actually even just to fly it required muscle memory to operate switches that you couldn't even see over your head because you couldn't do this inside the helmet and look over here. The helmet occluded you. Well, a simple sit down, you know, with a design team, with someone who'd worn a similar type of suit from the Air Force, could tell you, well, you can't look up. Or at least you can't see through the helmet, even if you can look up. There are the limitations there. So simple stuff that just could have been avoided. And all in all, we could have had, you know, that 20 to 40 launches per year instead if we had thought about it early enough. So HSI here at NASA is something we've been doing for a while. We just haven't been using the name really. The concepts that we're talking about aren't brand new concepts. Cost control and engineering lifecycle design, these are parts of systems engineering, and they always have been for many, many decades. The thing that we're trying to do a little bit differently, and by calling it HSI, is specifically that human consideration and making sure that it's, again, on equal par with all the other systems. This requires us to collaborate as a group, and all of these different organizational subunits have to fit together and talk to one another. Human health and performance is the one that I'm in, and some of us here in the room I know are. Mission operations, of course, is that operational era experience. You know, they have the training, they have the flight console ops, they have all that sort of aspect that they can contribute. The astronaut office would be, you know, of course, the flight crew end user. Engineering, the early design and prototyping. Safety and mission assurance, again, they're thinking about probabilities, they're thinking about operations era risks and things of that nature. Of course, you have to have the budget to get stuff done. And ground ops, of course, again, for prep, pre-flight, and also turnaround if something is reusable. So in the military, they have a set of 9 or 10 different technical domains that they've defined. And in their group, within different aspects of the military, they loosely map, but not on a one-to-one, with the way their organizations are set up. We also have found that it would probably be best not to just line up different organizations and instead think about the technical domains, because you might have people in each of these different organizations that have the same skills. There are human factors type people in ops, in MOD or former MOD. You have people who have, you know, medical types experience that are working in suit design. I mean, there's a lot of overlap, and we don't want to isolate and create silos based on organizations. Instead kind of bring that across from a technical expertise perspective. The human factors engineering is one of those domains, and this is the the detailed human interaction with a particular technical aspect of a system. It's not a process, and I have a slide that talks about this a little bit later, but HSI and Human Factors Engineering are different. Human Factors Engineering is a technical discipline, again, where HSI is a management approach. Ops Resource Management, again, they're responsible for things like remote operations planning, training, human effectiveness, maintainability and supportability. They're looking at the maintenance and optimize human resources, reduce errors, that sort of thing. Habitability, design and evaluation of the internal and external environments. Safety, looking at the execution of mission activities. And training, of course, the instruction and education for on-the-job activities and things of that nature. And there may be more. There may be new domains that we identify as we go along that we want to incorporate in this, but this is the straw man that we're working with right now. So there are 3 different types of people that get involved in HSI. We have the practitioners, the people who actually do HSI. We have the domain experts, who are the subject matter experts for something in particular. And then we have the process and organizational stakeholders. And I'll talk a little bit about who each of these people are. HSI practitioners are folks that would go out, they'd actually be embedded within a project or a program. They'd have a loose team, at the agency or the center level where they talk to one another and coordinate and things of that nature. But they'd also be, again, in the working groups for a particular project. They'd be in the integrated product teams. They'd be sitting in the technical discussions. They may even have a seat on a control board or two or somewhere along the line. And their goal there is basically to make sure that the human is considered. And so if the topic of chair design comes up, for instance, they want to make sure that someone responsible for suit design is brought into the discussion. They want to make sure that someone who has detailed information about anthropometry and physiology is brought into the discussion. They want to make sure that someone who has knowledge about restraints design and flail control and all that sort of thing gets accounted for. And the other kind of final thing that they would do is actually come up with tools and metrics for helping to measure how HSI is being done within the overall project. And we have more slides on that later too. So the domain experts, these are the particular SMEs that you would bring in. If it was, again, a chair design aspect, that would be the anthropometry person, the suit design person, the restraint person, making sure that they're available. And sometimes this involves doing a requirements gap analysis, looking at what the system design calls for and requires, and looking at what the product presented at PDR shows. And does that product account for all these different things? Have they done their homework, so to speak? And they would naturally, again, have academic backgrounds and experience relative to that particular expertise. The process and organizational stakeholders, these would be people who would either be using the system in the end, an operations manager or someone like that, a systems engineer, or it could be the designers themselves. They're involved in this, but it could be their bosses, their management, their higher ups, the people who are paying for the system, authorizing the systems, making the big decisions. Those are who we tend to think of as the stakeholders, but it also includes the people who are working on the line, so to speak. The reason I call out the buy-in for management is that that's critical. Things like this can be done at the grassroots level, everyone just doing their best effort, and that's kind of the way some of this has been done over the past 15, 20 years. But it's a lot better if the manager comes in up front, just like that DoD example, where they wrote the request for proposals and said, we want this human systems integration concept to be key to our proposals that we get back. When the manager comes in and says, this is about the human, this is about putting a man on Mars or a man on the moon or a man on an asteroid, and here's how we're going to do it. And that's very, very important. I mentioned before that human systems integration is not the same as human factors engineering. I won't spend a lot of time on this slide. Other again, just to iterate, it comes up in discussion. Sometimes we'll talk to somebody in a different group or something like that, and they'll be like, well, you're human factors. Don't we already work with you? And don't we already do that kind of stuff? And the answer is, well, yes, to some degree, but it's a little bit more than that. Again, the human factors is focused on specific technical problems and challenges, whereas the HSI is, again, more of this cost containment process. And an example might be if you're looking at the design of a robotic workstation, the human factors person might be looking at functional allocation, task analysis, hand controller design, heads-up display information, what's being shown, doing human-in-the-loop tests to basically evaluate that design as you go and make sure it meets the requirements. The HSI aspect instead would be working the technical management, the technical planning, making sure that people have the resources they need, making sure that they're being heard in these control boards and these evaluation groups, and ultimately tracking metrics as the project goes through its overall design life cycle. So, I won't really read this summary to you, that would be rather boring. Let's leave it up there for a second. Okay, so now talking about HSI in the systems engineering and integration life cycle. Take a sip here real quick. So systems engineering at NASA is, of course, based on best practices across the industry. And from those best practices, NASA has created a document called MPR 7123.1b. And this is the systems engineering requirements document. And basically, a systems engineer is someone who is based in the science of balancing the needs of the organization and the technical requirements of a complex system. They're really about that integration of many different groups together into a single project, looking at the big picture. So HSI very naturally is an aspect of systems engineering. It's not really a new science or a new field. It's just making sure systems engineering, again, considers the human. That means placing the human and software and hardware all on equal footing and not just thinking about the human at the very end. The way it's set up right now, the way systems engineering works, is a collection of 3 different kind of categories of processes. There's overall 17 different individual steps here. And I won't go through and read all of these other than to say it's a continuous flow back and forth of information between system design processes, product realization processes, and the technical management of those processes. And so system design, again, takes into consideration original requirements, stakeholder expectations, flow down of requirements and standards and things of that nature. Whereas instead, the product realization is coming up with the implementation, the integration, verification and validation, and transitioning to ops. The technical management juggles both of those, keeps them all in line, make sure they play well together. And the struggle, or not the struggle, the challenge has been how to make sure HSI fits into this process. So we've been fortunate enough that 7123.1b has been under revision and was revised back in 2013. And shortly thereafter, the Systems Engineering Handbook, which is kind of a guide to how do you make that work, how do you do this stuff. It's been in review and revision as well during 2014, and it's about to be published here this month. And in fact, I'm not sure if anyone knows, has it already been released?
No, it's in JSC review right now.
In review right now, okay, great. And along with that, folks such as Paul, who just spoke up, have been working on this HSI Practitioner's Guide, which is a step-by-step process that people who actually want to do HSI can follow to make sure that this is accounted for. And I have a slide that talks about that in a little bit of detail here in just a moment. But again, it's a very fortuitous time. This opportunity didn't exist 10 years ago. 10 years ago, when we wanted to do HSI in the Constellation program, we just had to create our own HSI groups. We had to create our own requirements documents and things of that nature. And they called them the Human Systems Integration Requirements Document, HSIR. So we'll talk about that a little bit more. But again, this is very fortunate for us to be able to do this. So again, the Practitioner's Guide here is a frequently used document, hopefully, to be frequently used, that spells out how to create an HSI team. Who can be engaged in the programs and projects, who are the team members, what is the background of the user expected to be, who is this HSI lead or practitioner, what is the scope of this document itself. It's really based on guidance for executing HSI for any different size of program or project, and it's based on inputs from the Office of the Chief Engineer, HSI Steering Committee. That's what this rather lengthy acronym down there stands for. And that steering committee, I believe, has been around for 2 or 3 years. And they've been trying to, again, come to consensus on how to revise the prior documents we showed on the other slide. The Practitioner's Guide goes a lot further than the Systems Engineering Handbook when it talks about HSI. And I haven't read the HPG myself, so this is a slide that I've gotten from Paul, so correct me if I'm misspeaking any of this. It helps you formulate the HSI team project needs, defines the tools that you'll need, specifies activities and products that the team will pursue, and has a tutorial related to implementing HSI. So this should be released here in March, shortly after the release of the Systems Engineering Handbook. And I thought I had a bullet in here as far as, okay, let me see. I'll hold off on that for another slide, sorry. So again, how do we map HSI into that systems engineering engine, that collection of 3 different types of processes, and how do they work together? Well, we break it down, again, these 3 different categories of system design processes, product realization processes, and technical management processes. Again, from the system design standpoint, you're looking at requirements definition, technical solutions, and to go along with that, from the HSI side, you end up looking at things like functional allocation between the systems and the humans, and the functional allocation, the ConOps, the concepts of operations, iterative human-centered design, and prototyping. For product realization, again, you're looking at the design realization processes. How do you implement things? How do you integrate them? The evaluation process is based on verification and validation. And transition processes are looking at how you prepare for ops. And again, the HSI emphasis here is making sure the human is considered during each of those aspects. The technical management probably doesn't change as much at the lower level of the human itself, because again, we're talking about technical management, but making sure that those human considerations have been taken into consideration. Okay, this is what the overall systems engineering lifecycle looks like. It goes from pre-phase A all the way to phase F. Again, you start with concept studies, go through technology development, preliminary design and completion, final design, system assembly, operations, then final closeout. And what we're trying to do is make sure that HSI fits into each of these different key decision points. As you go along, you've got metrics that you can measure. You can look at the program objectively, perhaps quantitatively, perhaps qualitatively, and evaluate, have they done their due diligence here? So again, these key decision points are key. That's where these metrics can be applied, and we'll talk about them as entry and exit criteria. Here's what you have as a vendor or as a program or as a project going into that key decision point, and in order to pass that stage, you have to have met the exit criteria. So it's kind of a pass through go, maybe collect $200, maybe not, and it's an evaluation period. So I won't go into too much detail on this particular slide, other than it also goes along with some of the key program reviews, such as the system definition review, preliminary design review, critical design review, and the flight readiness review. There is also a higher level document I haven't mentioned before. It's in this bottom slide here. The Human Rating Requirements Document, 8705.2b. It requires that you have an HSI team created to kind of manage this process. Now, I will say that that document and that requirement predate the practitioner's guide and these recent revisions to the Systems Engineering Handbook. It was written originally with that goal of making sure that HSI was taken into consideration. And so those inputs to these other documents that we've made are part of that realization, part of that process. And one of the things we've had to try to do is define, what is this HSI team? Who are the members of it? How does it work? How do you implement it? So looking at some of these different entry and exit criteria, these are the HSI activities by project phase. These are the activities, and I think the following 2 slides after these 2 actually have the metrics. For pre-phase A, when you're doing your concept studies, you'd want to identify the roles of humans in performing a mission, look at doing trade-off studies and analysis of alternatives of different possible designs and how would they be impacted by the human, or how would they impact the human. Develop scenarios and concepts of operations. In phase A, you'd already have your HSI team created, and you would have a human rating certification plan with some inputs to consider HSI. Crew workload evaluation would be one of them. You'd also have done functional allocation. What are the different things that the human is going to do? What are some of the aspects that automation would take care of? If there's a robotic agent on the mission, what is the robotic agent going to do? How do you divvy up all of these different tasks? What is the functional allocation? And we go through, I don't want to necessarily just read these off to you one by one, but there are several different criteria for each phase. Looking at phase C through F, we have things again like a report from the Human Rating Certification Plan. That follows for both phase C and through phase D. In phase E, you're monitoring human-centered design performance. And finally, at closeout, you're creating your lessons learned document, something you can push forward into the next system design. Make sure they don't repeat the sins of the past. So the actual criteria themselves spelled out would be systems engineering management plan, ConOps, technical products, all at pre-phase A. At phase A, you'd have an HSI plan created. You would have revisions to things like your SIMP. You'd have architecture baseline, and you'd have HSI technical products that you've created and identified. And then for phase B, you'd have human systems integration plan updates, continued revision and updating of things like your ConOps, creation of your verification and validation plan, and moving through to phase C, again, more updates to your HSI plan, ops documents in phase D, lessons learned, starting to write them during phase E as you're actually doing your operations, identifying what are the things that we're seeing as problems, what could be fixed in the future with another iteration, and then finally at closeout, finalizing those lessons learned. Any question here? This is kind of the real meat and potatoes of the HSI implementation here.
So,
Yeah.
I have a question. Human Health and Performance has been developing the concept of ops for the commercial crew and also for EPCV. Notice it says work in progress. I was wondering how active you've been in those document reviews and if you've been able to contribute to date or...
I will answer the question using the royal we instead of me. I have not personally been too involved in the commercial crew. I was at one time, and I was also in Orion at one time. But we have a team of, I don't know exactly how many people, just it seems like probably about 10 or so within SF at least that I know of personally that are engaged. And yeah, we have folks that sit on the crew, commercial crew boards on a regular basis. They're always engaged in the key discussions. I believe one of them is assigned as a, I'm not sure of the terminology within the commercial crew program, but like a subsystem manager. She represents all of our human consideration needs. We also have been going through things like revision of the commercial crew requirements document, CCT 1130, which has all of our human performance requirements. And several of us, probably far more than those 10, including myself, have been engaged in reviewing the plans from the different vendors to see how they map to those requirements documents. So we've been very engaged from the beginning. In fact, before the commercial crew program was even off the ground, back when it was still called C3PO, I believe, back around like 2010 or 2009, we had written several documents. One of them was the Commercial Human Systems Integration Requirements document, the CHSR, the Commercial Medical Operation Requirements document, the CMORD, and the Commercial Human Systems Integration Processes document, the CHSIP. And each of those documents was written before there really was a large funded commercial crew program with 3 potential vendors competing for, the eventual contract. And as a part of those documents, the CHSR was kind of like our HSIR document. It had the technical requirements spelled out. The CMORD is not one I'm as familiar with. I understand it's the medical operations requirements. The CHSIP, on the other hand, was a unique document. It was something that we hadn't done before within SF, at least, within the human factors community in general, where we actually laid out a how-to guide of how would you do a workload evaluation? How would you look at usability? How would you look at anthropometry compliance? How would you look at doing a handling qualities test? And we put all that out there, and that's now available to the commercial crew vendors as a resource, a reference document, if you will. I'd say the commercial program has been a real success story for HSI, as much as it could be, considering we don't own the systems ourselves. They're developing their own systems, and we're buying rides, basically. I think it's worked out very well. It's still in process, of course. We haven't gotten a final product, so we'll hold judgment until then. We'll keep working on our lessons learned. Yeah.
So that's a big project. How do you scale this down to tiny projects? We have hundreds of tiny projects that are $100,000 or less total life cycle cost. And they don't follow all of these phases. They don't produce all of these documents. What do we do to help our tiny projects with the human systems interaction?
I'm going to start by saying I have 3 or 4 slides just on an answer for that, but I'm going to go ahead and tell you. I'm going to go ahead and spill some of the beans ahead of time. So, the way we do that is we've created a community of expertise. There's an HSI group called the Employee Resource Group. It's an ERG, and mostly those have historically been social groups for collaboration with people to get together that have like-minded interests and things of that nature. I believe the HSI ERG that was created was one of the first technical ERGs made within NASA. Don't particularly quote me on that, but that's what I've heard. And the goal there is to create a collaborative environment that's not mandated, it's not set up under requirements and standards, things like that, where people can come meet each other and they can ask questions in the open. That's one place where someone who happened to have a small project could come and say, hey, you know what, I've got this going on. I'm going to borrow an example like from Corey Simon at the Wear Lab. He's got wearable technology he's developing. Obviously very important to be based on human considerations. It's something people wear. He happens to have a lot of HSI knowledge, but he still comes to folks like myself and my compatriots for information with some of the specific details that he might come up against sometimes. Like, how would this work? Do we have to worry about skin conductance contact? And he's thought of those things years ago, but still, it's the type of challenge that he might come to. And so he's a very active member of that ERG now. And I believe is he the current president perhaps even? I'm not sure. But there are also other ways if we have this overall implementation that we're still in the middle of, where we create an agency or a center-based HSI team that, again, isn't an oversight group. We don't want to do anything like that. That'd be far too costly. But a resource, a shared services type of organization, which the ERG is an early attempt to try to get that done at a free volunteer level. If there's some way that we can create something more formal, that'd be wonderful. And then people could go to that group. The other thing that has happened, again, with the systems engineering requirements getting revised a little bit, is making sure that there is a requirement there. So the smaller projects now, in the past, they may not have cared, first of all. And so getting HSI involved kind of starts in some cases, unfortunately, by having a requirement to get it involved. You don't want to use a hammer, but it's a work in progress. And so we have the requirement. That's kind of a step in one direction. We have the more social interaction with the ERGs, which is another alternative way to go with that, and bring it about early on. If people are aware of HSI, they can go and ask for help. I hope that helps. Yeah, okay. Any more questions? Okay. We're only about halfway, so I'll keep going. And this, actually, I should have gone ahead and just gone to the next slide. So this is how we're doing it at NASA. Primarily, it's been in the past been done with requirements and verification. We have our current requirements, like NPR 8705.2b, human rating requirements. They haven't really been applied to small projects. So how do we foster that collaboration? And I think I've already answered that question, so I'll just move on to the next slide. Some examples where things have been done very well. We have things like Flight Deck of the Future, virtual windows, e-textiles. Lots of people have been getting IR&D awards and ICA project awards, $10,000, $50,000, $100,000 awards. And there's been a lot of collaboration on those. I've been involved in a few of them myself. I know several of the people I work with have been as well. So I see that as a real success story. But it is important to kind of get the word out and share the information. If people don't know about it, it's hard for them to do what they should be doing there. The other thing is making sure that this overall concept of HSI is streamlined, that you don't have to have a program manager and human rating certification plan and all these other things going on for some small $50,000 project, which might only have one person funded at half time to do a little bit of work on developing something over the next 6 months. That doesn't leave a lot of extra room for 2 or 3 people to come in as a team and say, well, you must do this, you shall do that, and all that. So it is a challenge, and it's something we're working on. One thing that NASA has always done and has done fairly well is ConOps development. From an HSI perspective, that's a very good thing. That's one of the key aspects of HSI. The only critique that we wanted to make about the way that we've been doing ConOps in the past is that sometimes they're too high of a level. They don't go down to very detailed task interactions all the time. Sometimes they do, but not too often. And when they're done at too high of a level, they don't really help as much as they could. So the overall goal, the path to success is keeping the requirements of verification, things that we have in place. We don't want to get rid of those. But again, we want to make it more of a collaborative engagement, and we need to take HSI and elevate it away from final verification, again, and make sure that it's something that's proactive. We really need to sell it. I mean, if we can go to a program manager or project manager and tell them, we can save you 40% of your costs, you know, I mean, well, of course, that's kind of a no-brainer. Everyone would do that. So that's what we're trying to get to. You know, the DoD again has had many, many years and very large production runs where they've been able to show that. You know, 40% reduction, 60% reduction in costs, and that's been a reality for them. They've actually made that happen. We don't produce 10,000 units of something necessarily. We're not guaranteed to get that same level, that return on investment, but our operations costs, I think, from my understanding, tends to be higher than theirs. You know, someone operating a Humvee, you know, a couple of, you know, soldiers or servicemen, servicewomen, whatever, you know, they're not necessarily supported by, you know, hundreds of people on the ground and, you know, the cost of billions of dollars to get them into space and all that sort of thing. So our operational costs may far exceed their operational costs per given unit. So there's still a significant opportunity there. I'm not going to read through these in detail other than to say, you know, as a reference, if you go look at the slides after the fact here, there's a lot of different documents that have something to do with HSI and systems engineering. A lot of the stuff that we've pulled into this presentation have come from these sources or been worked into these sources, as mentioned before, as they've gone through revision. And it also includes specific ISS and Orion and commercial crew documents. So there are three keys to having a successful HSI program. The one that I've probably spoken the most to is making sure that the human is as important as any other system, any other component of the system, and you know, that it's given equal weight as far as, you know, not just requirements, but also resources and input. And one of the questions that we're sometimes asked is, well, this is kind of obvious. This is common sense. Why do we even have to teach this stuff? You'd think everyone is already doing it. And I run into that in the classes I teach on human factors as well. And it's true. It's a valid question. We're all people. You know, an engineer is sitting at a CAD workstation designing, you know, a knob and a control panel. You think, well, you know, that person has hands. You know, they have eyes. They understand, you know, what they can grab onto and what they can't. The problem is we're all unique. We're all a little bit different. And so I'm 6'2". I've got medium-sized hands. If I design a system, you know, and I think the knob has a certain force required to turn it and the ridges on the knob are a certain way, well, that works for me because of my particular musculature and the size of my hand and, you know, the presence or absence of calluses on my fingertips or whatnot. All that might feel fine to me. Someone else might grab it and say, oh, this thing is too hard to turn. It hurts my fingers. The knurling digs into my skin and, you know, that sort of thing. It's uncomfortable. Or you look at the hatch to egress from a capsule or something like that. You know, for me, 25 pounds, no big deal. But for someone else that's deconditioned after being in space for 6 months to a year, that's got all sorts of neurovestibular problems going on because they've just re-entered and they're trying to open that hatch, that's a whole different story. So you really need to quantify that. And that's really what it is. We're all kind of biased to our own personal perspective of reality. And this forces us systematically and scientifically to consider other options. So HSI also depends, again, upon integration and collaboration of all these domains. And one of the things that we see in other agencies, and we see it here at NASA as well, is that sometimes the domains are siloed in some regards. You know, you have people who are excellent at what they do. They have, you know, great scientific and engineering expertise, and they do what they do and they do it well. But they may not necessarily play with somebody else. And maybe there's a need for those two data points from each of them to come together in that system design to make sure they function well together and that they're actually designing towards the same goal. And that's a very key thing to have. And so, you know, this aspect and this concept of an HSI team is to make sure that they do meet and they do integrate and they do talk well with one another. And the barriers, sometimes ask, well, people again know this, you know, why aren't they doing it? You know, this is kind of obvious. That's why we have integrated product teams. That's why we have working groups. And the answer is basically that sometimes, well, it's for a variety of reasons. Sometimes people want the barriers. They're not comfortable socializing maybe or something like that. Or maybe, you know, they think their scientific field is the most important one, and the other one just doesn't have the priority. And that's fine if they're the expert in their system, but still, as a project or as a program, you have to integrate them. And they can't be siloed intentionally or accidentally. Finally, key 3 is that HSI has to be considered early and thoroughly in the concept design of requirements, just because, again, that overall chart of cost and how you can make those changes very, very cheaply, almost for free when you're writing the draft RFP, versus once you've actually got something past PDR and it's approaching CDR, and whoa, stop the hoorays, we got to tweak this control, or we got to add this display or remove that display. It's much, much more expensive at that point. And so your HSI plan, again, would document all of your criteria for getting from that beginning stage to the ending stage to prevent that from happening. Go through a couple of little myth and reality things here. Designers intuitively understand the human needs of the system because, after all, they are human. And unfortunately, as I mentioned before, everyone is accustomed to their own particular perspective on reality. We're all people, we're all biased, we can't help it. It's part of just the way we are. Second, that training is a cost-effective way to work around design shortcomings. This seems silly, obviously it's a myth, but there was a time when that was, the real kind of mindset that, don't worry about it. The crew are intelligent, they're the best of the best of the best. We can train them to do it. But, even the best of the best of the best throw up in their suit or, pass out or whatever. You gotta take that in consideration. And so proper designs reduce the needs for training, and design it right the first time, and not accept any unnecessary risk that you don't have to. Next, adding HSI to a program or project costs money we may not have. Again, that's very easy to see from the myopic perspective of just one aspect of the overall life cycle, just the design aspect. But when you look at the operations cost, that's really where you get the return on investment. And one of the ways the DoD has done this is making the design people accountable in some ways by having a shared life cycle cost for some projects. Not all, it's hard to do, but it's something they have experimented with. And again, making sure that we have ways that we can measure and estimate that overall operations cost. That'll be a key thing. And without that, we're always going to be playing a little bit of catch up, but that is something we're working on. And the DoD has an equation that they've developed. Again, we don't have the orders of scale that they have, the numbers of production volume that they have. So that equation won't work for us. We have to come up with our own equation. But we know it's possible. It's been done before, and we can do it here. And then finally, HSI can reduce life cycle costs by using the existing SE practices and systems thinking to create human-focused products. And that is the reality. That's what we're trying to do. Not create an overall new engineering life cycle, not change the way NASA does business. Again, just make sure we're integrating this one additional component in a very methodical way. It's always been personality-based in the past. We've had some great HSI success stories, and we'll cover that in the last few slides of the presentation. But it's been because people had the foresight. They went out and they got engaged, they did it, they took on that role even though it wasn't something they had to do. And that brings us to how do we implement? How do we make this happen? So I've mentioned these terms before. The things that we're going to have is an HSI plan, an HSI team, and metrics to track progress. So starting off with the HSI plan, this would be something that each project or program would have, and it would be a living document that changes and progresses as they go through the engineering life cycle for a particular system. And it would define the goals and deliverables for each of the different phases of the project, through pre-phase A all the way through phase F. What are the entry and exit criteria? Define them from the very, very beginning so that you can stay honest with yourself as a project or a program. Defining the roles and responsibilities for who's included. What are the methods and tools and requirements? List out the different issues that are anticipated. What are the risks that need to be solved and mitigated? And it could be part of the project systems engineering management plan, or it could be its own plan. And that HSI practitioner's guide, I believe, has some ideas for how to write an HSI plan. The plan is typically updated again as you go through each phase after each key decision point. And again, a template has been in work and is either going to be part of the SE handbook or part of the practitioner's guide, hopefully.
Currently, the handbook doesn't mention the practitioner's guide.
Okay. Paul, do you have any input for that?
Yeah, since the practitioner guide is still just in draft, it hasn't been described in the handbook itself.
Okay, because I'm working on the handbook. as well.
Right now.
There's nothing about the practitioner's guide in there.
So from what I understand, again, from information from Paul, is that the,
Maybe-
yeah, is that
Maybe
the,
we should put in a reference and say it's a draft form or something like that.
Make that comment.
So the HSI team would be the next key component. Again, this is composed of stakeholders, domain experts, and HSI practitioners. And according to the goals here, we'd want to have that stood up by the system readiness review, according to the human rating requirements. And it's almost always needed, for the larger scale projects. Again, at the lower level, a $50,000 project don't necessarily need this much infrastructure. But a $2 billion, $5 billion project, definitely there's going to be enough complexity. You'll need this. Again, it's not an oversight role; it's a collaborative role, and these are just team members that are engaged, working with working groups, IPTs, and control boards, and they just make sure that the right people are brought in at the right time and help track the costs and the metrics of the program. And they also help identify, resolve, and track any issues that come about. They make sure that test and evaluation efforts are present and tracking the HSI requirements and updating the HSI plan as, again, you move through the SE Lifecycle. So the metrics, that's kind of the tough part. How do you measure something as nebulous as, well, has someone considered the human in this part of their design? I mean, it's a tough idea, and it's one that we've all struggled with, working on this presentation and on the practitioner's guide and all these other things. We've tried to leverage from what other people have done in the DoD and the military and other agencies and things like that. We have some good ideas. One of the things that has been done before is the use of checklists, just to track that certain domains have been involved and integrated, that certain things have been considered, and I have a slide with an example of that here in a little bit. You can also look at crew time or efficiency measures for task completion. Again, you can do that in pilot testing and pilot studies that you would do as the development cycle goes through, not necessarily waiting for verification and validation. That's too late, but doing it early, very early in the design. And having conduction of domain trade-offs, if you have two different groups that have to be integrated, you can do design trades, look at how they would play well based on the human consideration, and formulate plans and track your progress on those HSI plans. Again, to be another one. So one example of a checklist would be this slide and the following one, I believe, where you might start by defining the scope and planning effort by appointing an HSI lead. That's something that you have to get done. So you would look at how this particular program compares to others as far as what is the scope. Are we over-including HSI? Are we burdening the system? Or are we doing what we need to do? Looking at the planning activities, coordinating with the PM, developing a meeting schedule, developing planning assumptions. Have those things happened? Have you coordinated for external support, other SMEs that are outside of your group that may need to be brought in? Have all the different relevant HSI standards and requirements been flowed down? Have they drafted an HSI plan? How does it compare with other plans? Is it inclusive enough? And there's some other things here, again, with the team and HSI domains, again, just kind of tracking, are things being done the way that they should be done? So a checklist like this is very simple. You just go through at the point where you go into a key decision point from pre-phase A to phase A or phase A to phase B. You sit down and evaluate the program. And this is something the HSI team might do together. And I'll go ahead and move on through. So having talked about that, those are kind of the nuts and bolts. And again, the practitioner's guide that's coming out again here in a couple of months is going to have a lot more information in it and some real templates and examples. But to show that it can be successful, here's some success stories that we've done over the past decade or so. Going back to 2003, the Constellation program is being formed, and some pioneers within NASA identified that HSI was in need, that it was something we really needed to do, and they worked with the Constellation program and ended up developing something called HSIR. Again, I mentioned before the Human Systems Integration requirements, and also created an HSI group, creatively named the HSI group, the HSIG. And its goal was, again, to look at the HSIR document, see how requirements were followed by the different projects within Constellation, and try to help and develop technical expertise to facilitate this. So in a way, this HSIG was an early HSI team. They didn't have a mandate from the Systems Engineering Handbook. What they had was recognition by people with foresight at the project level and at the program levels and at the support level. So within SA, where some of these technical human factors people resided in the different HSI medical aspects and things, that's where they were. The engineering groups understood and recognized the need for them to be involved. And so that collaboration was born. In fact, early on within the Orion project, there were some different requirements that were included in the RFP, the draft RFP that was being written. They got pulled out before it ended up actually being released for vendors to look at. But as an alternative, they created the Cockpit Working Group, which was and is an interactive body that includes crew representation, prime contract representation, and HSI representation. And all other subsystems that are involved, avionics and engineering and things like that, they get brought in as needed for particular aspects and particular issues. So they worked across all the different projects within the Constellation program. And activities included, again, HSI requirements development, helping to review those requirements. Interpreting them was a big part. Prime contractors would come to the HSIG and ask questions. How do we implement this? This requirement sounds vague, which is a very legitimate concern. And so the HSIG and they bring in technical authorities, SMEs. They would work with the HSIG and with the prime vendor to help come up with a definition that thoroughly explained, what was the rationale, what was the real intent of the requirement. A very collaborative approach, very good success story. And a lot of human-in-the-loop evaluations were done, and I believe are still being done for Orion right now, as a matter of fact. Other things that were done were creating new requirements from scratch as new issues came about that we didn't know about. Thrust oscillation vibration was something that hadn't been originally included in HSIR, it just wasn't identified. But once the idea of creating a capsule and putting it on top of a solid rocket was looked at, from a computational perspective and the thermodynamics of it and the vibration aspects of it from an engineering perspective, they were like, whoa, that's a sizable dose of vibration. Can a human survive that? And we didn't really know. And so we went out and we actually did some testing. Some testing was done at Ames with help from JSC and the crew office and medical people and the prime contractor, and looked at what are reasonable requirements for thrust oscillation. What is the most at which you can go before someone starts to get addled, or they just can't read something, they can't operate an abort button perhaps. And all these different considerations were taken into effect. And they created a new requirement that everybody could agree on. It was very reasonable. And another example was in the very beginning of the Orion project. There was a very in-depth task analysis performed that created a master task list. This was more detailed than a lot of generic ConOps have been done in the past. It was a very good reference for different stages of the given mission. Separately from that, there was also this thing called the HSI broadcast that was done. SMEs, myself, and about 5 other people stood up for about an hour and a half and talked about what we do. We weren't really going into HSI as a process, more talking about it from different technical domains. And that was being shared with different stakeholders. They were invited to these broadcasts, and they were, I believe, actually available perhaps online. There's a website you can go and you can still watch those videos even now, 4 years later. And hear from Rick Schuring about medical aspects that were of a concern for him at the time in design. I talked about human factors. I believe there was a person talking about the integrated medical model and several other different technical aspects. Really cool stuff, and I believe that's the link where you can get to them right there. The other thing that we did, this was an early take on metrics of the checklist variety, was an HSI scorecard. Again, there was no mandate for this, there was no requirement for this, it held no weight, programmatically speaking. But the HSI practitioners, again, within this HSIG, and working with the Health and Medical Technical Authority said, well, why don't we go ahead and create our own checklist? It's not binding, it doesn't, no one's beholden to act on it or anything like that, but let's just track it ourselves. Let's look at this, and we'll share the results with the different subsystems, and we'll share the results with the prime contractor and with the program manager. The project manager. Just let them know this is what we're seeing. And lo and behold, it actually had a huge amount of social weight, even though it didn't have programmatic requirement weight. There was one particular instance, I hate to name groups, not even just names of people, but groups. I'll just say there was a particular group involved, a subsystem, that had a design. And that design was evaluated in a human-in-the-loop fashion. Recommended changes were detailed, a very detailed list, and they were ignored for over 2 years. And so when that particular subsystem came up for review again at a following design review, the scorecard results showed 0 improvement and that kind of stuff. And that was shared with the manager for that subsystem group and with the project manager. Not in a hateful way, kind of a, look, we're really trying to get you to make these changes. It's really important for these reasons. It's been 2 years, nothing's happened. We have this metric that shows nothing's happened. The project manager was aghast. I mean, he's like, whoa, that's unacceptable. We have to be making improvements here and things like that. They went off and they completely redesigned that particular component that was under evaluation. And they were very collaborative after that. They were very enthusiastic. It turns out it wasn't any kind of a malevolent, ignoring of the recommendations. It had just slipped through the cracks. The person that had gotten the report with those recommendations, said, well, those are nice to haves, but they're not really required. We'll set it aside, and when we get time and when we have more money, we'll address them then. Well, that never happened because we're always short on time and short on money. So just an example of where it had a positive improvement. Again, we talked a little bit before about the commercial crew program. I don't really need to rehash that too much other than to say that that was a very big HSI success story. A lot of good inclusion there. And I mentioned before the creation of the HSI Employee Resources Group, which again is a social organization for sharing HSI expertise. And there's been an HSI steering committee created underneath the Office of the Chief Engineer. And that's about it. So we've talked about what is HSI, how does NASA look at HSI from a program perspective, how do we make it fit into systems engineering. As far as the future of it, again, we have these recent documents that have just been revised that are coming out. We have future large projects, we have future small projects, and we want to make sure that HSI is a consideration in a positive way. Again, trying to save costs. If there's any one takeaway from this whole presentation that I'd hope people remember, is that you can save a lot of costs with this in the long run, because even if you don't do it in the design cycle, you'll probably get through your decision points, you'll probably get to the, to the readiness review, and your project will be released. But if it's not paid for then, it's going to be paid for at a much higher expense at the operations phase. And people, possibly not think well of the system because of the lack of that consideration. So that's the hope. Again, try to save costs, try to make it work better. Things you can do, there's been this class you've already taken. I know that some of our folks are wanting to create a certificate program here at NASA. There's also an additional certificate program that's held by the Naval Postgraduate School out in, I believe it's San Diego. In fact, we had the manager for that program come out here, Larry Shattuck. He gave a presentation about 2 years ago on HSI. And here's a link for the Naval Postgraduate School. If you're not already a member of the HSI ERG and would like to, Deb Newbeck is one of our contacts for that. You can give her a call. She's in Global, and ask her to get on the email distribution list. Of course, the HSA Academy. We have classes like this, and there will be others in the future. And I guess there's a lot of stuff online. If you're curious, we have an HSI library that we've created. We're setting it up on a new SharePoint site. If you're interested in seeing some of the documents that sourced all this material originally, you can drop me an email. I'm in Global as well, and I'll share you that information. So, any other questions? I think that's all I've got. All right, I appreciate it. Oh, we have a question.
Where
Okay.
are those charts going to be posted?
I believe in the past they've been on the HSA, the Human Systems Academy website.
That's what we're going to.
It's okay.
Yes, on
So
the system.
maybe in a week or two or something like that. Okay, great. Awesome. Well, thank you very much. I appreciate it.